In this session, we are going to learn a new thing. To most people, you have not learned this in the lower years. In the lower years, you have probably come across this thing called the scalar product or the dot product. In the opening chapter of this module, you are learning a brand new thing for most people. This thing is called the vector product. It's a new thing. So as a new thing, what we need to first and foremost do is to understand the definition. So the definition of cross product, if you have two vector A cross B, by definition is the magnitude of A times magnitude of B, sine of the angle between them. This is the angle between them, and then times n cap. I hope you can recall a notation such as this, n with a cap on top represents what is called a unit vector. A unit vector is a vector whose magnitude is 1. So cross product is defined like this, quite lengthy, right? So to compute A cross B, you really need to find this, this, and this. So there are 4 things actually you need to find. So this diagram is trying to make you understand geometrically what is A cross B. A cross B will produce for you a vector like this, the red color vector, a vector that is like this. In this diagram, it also tries to tell that, that when you do A cross B, the end result, which is a vector, and this vector is actually perpendicular to A and also perpendicular to B. Can you see? The diagram is trying to tell you this, right? So this vector n cap is actually a unique vector that is somewhere here. Can you see? A shorter version, a shorter arrow here, right? N cap, whose magnitude is actually 1. So to find a cross product, you really need to find this, find this, find this, and you need to find the vector n cap. All right. So now to go on from here. Okay, so let's go on from here. It's easier to learn exactly what is cross product by looking at a simple example. Supposedly, I have a vector A and a vector B. A cross B by definition, which is like this, is found by working out the magnitude of A, the magnitude of B, the sine of the angle between them, and then the vector n cap. Now, I have written them down for you here. I will explain to you one by one how I obtain all these values. At least for the start, finding the magnitude of A would not be too difficult. How do you find the magnitude of a vector? Remember, you square this number plus the square of this number plus the square of this number. You add up together and then you square it. Try doing that now. Take square of this number, which is 9. Square this number is 16. Square this number is 0. You add up together, you get 25. Square rooted, you give you 5. And to find the magnitude of B, square the 5, square the 12, square the 0, added together, you get 169. You square root 169, you get the number 13. But you'll be very puzzled how I got sine theta as this and how I got my n cap as this. I'll show to you in the subsequent slides. Okay, first and foremost, to find the sine of the angle between the two vectors A and B. And to do this, right, you have to recall what you did in dot product. In the case of dot product, right, if I take a vector A dot B divided by its modulus of A and the modulus of B, in the earlier module, you have learned that this calculation give me so-called the cosine of the angle between the two vectors. This is something that you have actually learned in dot product. If you were to move the denominator to the left, it is exactly what you have learned about the definition of dot product. dot product of two vectors is the magnitude of the first vector, the magnitude of the second vector times cos of the angle between them. Right, so making use of dot product that you've learned previously, I could actually compute the cos of the angle between them. And this arithmetic of dot product, I hope you recall, is just this times this, plus this times this, plus this times this. You get minus 15 plus 48, you get 33. Then the magnitude of this is 5, the magnitude of this is 13. You time together, you get 65. So in this calculation, via the use of dot product, I have managed to find cosine of the angle between them. However, if you look back, you want to realize that what you need is actually the sine of the angle. Tell me, if you know the cosine of an angle between two vectors, how would you find the sine? If you know cosine, how do you find the sine? And with the cosine of the angle between the two vectors, how can we find the sine of theta? Alright, of course, it's something that you probably have guessed it. The calculation to find the sine theta is simply by making use of what you have learned before in the earlier years, right? Haven't you learned this before in the earlier years? In the earlier years, right, we have learned that the sine of an angle is equals to the square root of 1 minus cosine squared. It's a very simple trigo identity. And then going through this arithmetic, we have managed to get that the sine of the angle between the two vectors, in this case, is 56 over 65. Having found the angle sine theta, we have the next task to do, and that is we need to find the vector n cap. Now, if you had noticed in the definition, I have said that the vector n cap, it must be perpendicular to A, it must also be perpendicular to B, and it also must be a unique vector. What I didn't tell you in the definition is this vector n must also obey what is called the right-hand rule. Right? So what is the right-hand rule? Let me show you a simple illustration. Okay, look at my finger. As my forefinger curl from A to B, the direction of my thumb will be the direction of the vector n cap. Can you see? As I curl from A to B, my four fingers, that is the direction of the vector n cap. For this reason, I have therefore chosen my vector n cap based on this diagram to be a vector that is pointing downwards, and to be a magnitude of 1, I have therefore chosen the vector 0, 0, minus 1. Now, I want to tell that for this example, I have chosen my A and B so carefully that because they lie on the xy plane, I can therefore actually find my vector n cap quite readily. Why is it so? No, because see, if these two are on the xy plane, to have a vector that is perpendicular to A and B is either a vector that goes up or a vector that comes down along the z-axis. So from the earlier presentation, you have understood that I have chosen to go down because of the right-hand rule, and to be a unique vector, my n cap therefore has to be 0, 0, minus 1. So with all these things, with all these four things found, if you go back to the slide that I have here, I can now find my A cross B by writing down the magnitude of A, the magnitude of B, the sine of the angle between them that I found using dot product, and the trigo ratio, also trigo identity, and then the vector n cap, which is 0, 0, minus 1, and this works out to be 0, 0, minus 56. As you can now imagine, finding the cross product of two vectors in this process is really non-trivial. It's not easy, especially if the vector A and B are not as nice as what I've chosen in this simple example. Not to worry, actually there is a way out. I want you to know that actually, apart from finding cross product the way I have shown you, there's actually an alternative way that we can work out the cross product. An alternative way that is equivalent to what you have just now. But your vector A and B must be given in what's called the column vector form. So if you have two vectors A and B in the column vector form like this, and B like this, what you did earlier on could also been done by doing this. It's quite a lot, right? But let me show you how this arithmetic comes about. What you do is you cover the first row, you cover the A1 and B1, you're left with these four numbers, right? These four numbers form a matrix. How do you find the determinant of a matrix? Remember, in the lower year you learn about matrix, right? To find the determinant of a matrix, what you do is you take this times this minus this times this, and that is actually the first row. You can see the first entry. And then what next thing is you cover the middle row. You cover the middle row. Again, you have four numbers 1, 2, 3, 4 after covering the middle row. And then with the four numbers, and once again I can find the determinant, this times this minus this times this, and then you have this number here. Just that for the middle row, you got to add in an extra minus in front. And then next, if you cover the third row, right? Third row, you have the four numbers again, and then you perform the determinant calculation, you get the third number. So what I'm trying to tell you is that although cross product was shown to you to be computed in a manner earlier on, which is quite a bit of effort, I want you to know that equivalently, cross product can also be found using this simpler alternative method. So just to illustrate to you that it works. Earlier on, you have these two vectors, remember? We found the cross product of these two vectors through that long process. Now for the same pair of vectors, if I cover the first row, I find the determinant, this times this, minus this times this, I get the value of 0. I cover the second row, I take this times this, minus this times this, I still get 0. Actually, I need a minus, but it really doesn't matter from middle row's case because it's 0. Whether I put minus or not, it makes no difference. And then I cover the third row, I take this times this, and minus this times this, I get the number minus 56. It's really like magic, right? What you did earlier on as compared to this is quite a lot of difference. It's so much easier using this alternative method, right? So what you have here is actually a definition for cross product, which can be computed from the definition. And now what I'm showing you is actually you have an alternative way to do the same thing. Let me show you with another example. Again, if you have two vectors A and B, right? To perform the cross product of these two vectors, you cover the first row, you take this times this, and this times this is here, and then you get minus 42. Cover the middle row, you take this times this, minus this times this, you get a second, but just that you got to add in extra minus. The middle row always require the extra minus for the middle row, okay? The extra minus, must remember, okay? Must remember this extra minus, and then get, in this case, 12. You cover the third row, 8 plus 14, you get 22. And this is how you get the cross product of two vectors using so-called the alternative method. Now, now that you have this alternative method to calculate cross product, you mustn't forget what actually is cross product. You must recall that cross product actually obtains a vector that is perpendicular to A and B, right? Like in this case also, if you cross product A and B, in this case, right, following the right-hand rule, it produces a vector that is perpendicular to both A and B. So this is actually the essence of what is called the cross product, something that is quite new to most of you. So with this, we end our session on the discussion of what is a cross product. We'll do more examples in the tutorial.